welcome to Physical Sciences session. My name is Temba Ncube. Today we are focusing our attention on a very exciting, kind of a session whereby I'll be giving you clues which have to do with the physical properties of materials. At the end, we want to identify, a specific type of material based on those physical properties. So it's going to be very exciting. Hence, I would refer to the name as a game that matters. It's kind of a catchy phrase. Let's see what exactly this is all about. Right. Okay, so in terms of the concept map or the mind map, and as far as matter is concerned, our focus today is on physical properties of materials. However, as I've indicated, we'll do it in a somewhat different way. I'll be dropping some clues. At the end of the day, we must identify a material that we'll call X for now, based on those physical properties. So our understanding of the physical properties therefore becomes very critical. Right. Okay, so it's a classification challenge, as I've put it out there. It says here is a list of 6 substances, okay? You can think of them as materials. We've got sodium chloride, okay, that's one. We've got copper, we've got sulfur, we have got water, we've got chlorine, and we have silicon. So there is a total of 6 substances. So what's going to happen here, I'll be dropping some clues along the way, such that we must identify material or substance X from the 6 that is given. So our understanding of the physical properties will be very important in terms of guiding us to the correct substance in terms of identifying it. So it has a lot to do with the classification. So along the way, we shall be eliminating. Okay, so as we eliminate, at the end of the day, we'll be left with the correct one at the end, and then we can say, okay, material X is whatever of the 6 that is given to us. Okay, hence we are saying it's actually a classification challenge. Right. Okay, so they all have different properties, these materials that we've listed, the 6 of them, and our focus is on the physical properties. Okay, and you remember very well, when we talk about physical properties, we're talking about the macroscopic properties of materials. That has to do, with electrical conductivity, density, malleability, ductility, boiling points, melting points, the list goes on. So think along those lines as we talk about, the microscopic particles, properties of materials, which is exactly what we'd refer to as the physical properties. Right. So the way particles are arranged will also be different. Now let's understand something. Which is very important. The packaging of materials will definitely influence the physical properties. So if the packaging is different, then it follows that also the physical properties of these materials that we've listed, the 6 of them, would obviously differ. Now we'll look at one property at a time and begin to eliminate as we go along. Right. Okay, so what do we have? We've got substance X. So substance X is unknown, okay? Let this unknown substance be X, okay? I think we're familiar with that approach. It says substance X has properties like one of our 6 substances, okay? Right? So it means, in other words, X is one of the 6 that is given, okay? It says there are no particles in X that are not present in the 6 substances. It means now, let's go back to the basics. All matter consists of particles. So if substance X consists of particles, all these other ones, because in their own right, they are also different forms of matter, it also means that they are also made of particles. But how these particles are arranged, and the behavior of these particles will obviously differ. Why is it so? Because these are different materials or substances, right? And then it says there are no particles in X that are not present in the 6 substances. We're still saying the same thing. All the 6 substances, including X, is made up of particles, right? So our challenge, okay, that's the main thing, is to work out what substance X is. So at the end of this session, we must be able to identify substance X, okay? So this will be based on the clues about its physical properties. So pay careful attention to the physical properties that will be given and try along the way to eliminate in as far as the 6 substances that are given, so that at the end of the day we are able to say, yes, indeed X is this based on the physical properties that we shall look at one time, at one at a time, right? And then it goes further and says, okay, this is about physical properties. So emphasis is on the macroscopic properties of material. So we would say these are macroscopic particles, macroscopic properties of materials, okay? So this is what it's all about, okay? Right. And then the keywords, because language is very important, it is the tool of the trade. So we shall use the very, some of the terms, once too often than others. The term element will be very common. You know, elements are particles that make up, you know, substances. And these elements are actually made up of atoms of the same kind, okay? So we also know something about compounds, which is a combination of elements that are joined together. So it's something that we already know by this time, okay? So, and when you talk of elements, hence we talk about the periodic table of elements. So any substance that is in the periodic table is actually an element. So hence we would refer to it as the periodic table of element, okay? So it means that all those materials or substances in the periodic table, they consist of the same type of atom. Okay, so an element has got the same type of building blocks or units, which we call the atoms. We'll talk about that. So here's an extract of a periodic table, and I think from our earlier studies would remember that we've got, you know, the vertical columns, which we refer to as groups, as well as the horizontal rows that we referred to as, you know, the periods. And also, we managed at an earlier grade to also look at, you know, the first 20 elements. So whatever is in the periodic table, it is an element because we refer to it precisely as the periodic table of elements. Right, okay? So there's nothing new about that. Okay, so we are saying that elements in the same group have similar properties. So group 1 elements, that's the first column, have got these elements, your hydrogen, lithium, sodium, you know, they've got the same type of properties. Okay, so the groups, they go vertically downwards, okay, and then the periods, they actually go horizontally from left to right. So from top to bottom, we've got groups, and then from left to right, we've got what? Periods, okay? So this is the period, okay? Hence, we call it the periodic table, okay? Now, elements in the same group have similar properties, and it can be physical or chemical properties, but our attention for now is purely on the physical properties, okay? Now, what else do we know about the periodic table of elements, just to remind ourselves of it? Elements in the same period have different properties. This is very, very important. Initially, we say that elements that are in the same group, they exhibit or show similarity in terms of properties. But then if we go across from left to right, we are saying that in the periods, because the elements in the same period are actually in different groups, hence their physical properties will definitely vary or differ from each other, right? So elements in the same period have different properties. That's a very important one. And then the pattern of properties is repeated for each period. Hence this has to do with what we call periodicity, right? So if you talk about periodicity, we talk about the repeat in terms of the properties of materials within a period. The trend is repeated for every period. Hence, we call it the periodic table, right? Right. And then furthermore, let's look at a simple example, the pattern of melting points. Okay, if you check carbon, silicon, and germanium, they are actually in the same group, and you realize that their melting point for each of the periods is actually comparatively greater than the elements within the same period. And what's so common about carbon, silicon, and germanium, if we go back to our periodic table, you'll see that carbon, silicon, and germanium are actually in the same group, okay? So the physical properties of those materials is actually the same. But if you look at the periods in which each one of them falls, obviously they'll differ in terms of the physical properties. So the main thing here is that elements within the same group have got similar physical properties, while within the same period, they would obviously differ, right? So that's the main idea that we want to kind of carry across, right? Now, this is the pattern of melting points. Remember what we would have understood in terms of the melting point, the temperature that a material changes from one phase or state to the other. And that's also an indication of the strength in terms of the physical properties. So if you take, for argument's sake, copper, which has plus minus 1084 degrees Celsius melting point versus that of water, which is like 0 degrees Celsius. Now, it says to us that this copper has a comparatively greater strength as a physical property in comparison to water. So there's a lot that we can derive in terms of the physical properties based on these trends, right? Okay, so here the melting points of elements in period 3. If you look at sodium and magnesium, aluminum, silicon, they are in the same period. It means they fall in the same, horizontal row. Okay, as you go from sodium to silicon, what is happening? The melting points is getting higher and higher. And then if you go next to potassium, phosphorus to argon, the trend is downwards. So this is what we mean in terms of patterns and trends in as far as periodicity is concerned. So it says within a group, the physical properties are more or less the same, while within a period, the physical properties will obviously differ, right? Okay, so here's a list of the 6 substances which we have already looked at, the 6 substances, okay? The game is about, classifying and also at the end of the day, identifying what substance X is, okay? The question is, are any of the substances elements, okay? What is an element? An element is a material or a substance that consists of atoms of the same kind. And where do we find elements, in our sources? It's in the periodic table of elements. So that's the main question. Think about that, okay? So if that's the case, all elements, copper is a metal, okay? You'd understand if copper is a metal, it means copper is also an element. Okay, there is copper, okay? Element number 29, okay? Silicon is also another element because it consists of the atoms of the same kind, okay? And then moving forward, okay, silicon is a semi-metal, okay? So in other words, in terms of classification, all metals will be more to the left of the periodic table, while to the right, we've got non-metals, okay? While in between, there's a collection of few semi-metals or metalloids. So the term semi-metal suggests that the material has got a combination of metallic and non-metallic properties. So the words semi-metal and metalloids will actually be used interchangeably to refer to the same thing. So metalloids are semi-metals, semi-metals are metalloids. So the two terms are referred to one and the same thing, right? Okay. And then we've got chlorine, which is a non-metal, okay? There is our chlorine, okay? Element number 17, it is a non-metal. It falls far to the right of the periodic table. And if you look at the group, they are in group 7, okay? And this one is actually in period 3. So chlorine is in group 7. So we would expect, like we have said, chlorine to have more or less similar physical properties to fluorine, bromine, iodine, because they fall in the same group. So chlorine is a non-metal by classification, right? And then we also have compounds as part of the keyword. You don't find compounds in the periodic table. However, the constituent components that make up a compound are in the periodic table because these are essentially the elements. So elements that are joined together, they form compounds, okay? And these elements must be different, okay? So there is, in the list that were given, what elements present in the compounds is one of our 6 substances. Let's identify the substances that are actually compounds. We've got sodium chloride. Sodium chloride actually consists of sodium and chlorine. So this is a compound in the sense that it's more than one element that is chemically joined together. Okay, the other one is obviously water, which is another compound, right? Okay, and then having said that, okay, we also appreciate that we are able now to go back to the periodic table and ask ourselves important questions in as far as what are these substances? What elements make up those particular substances? Now, the 6 substances that have been given to us, we more or less have an understanding in terms of classification. Are they elements? Are they compounds? We have managed to actually arrive at that kind of an understanding. Having said that, let's take a short breather. Then when we come back, we'll start dropping the clues and trying to eliminate so that ultimately we remain with our substance X. Let's take a short breather for now. Welcome back to our second segment. We're still looking into the physical properties of materials. So now we want to look at the clues in terms of the 6 materials that we're given and try to eliminate so that at the end of the day, we are able to identify what exactly substance X is all about. So on to our first clue, substance X does not conduct electricity, okay? So substances that do not conduct electricity, we are saying that they are insulators, right? Remember, an insulator does not conduct either heat or electricity. So if it doesn't conduct electricity, it's an electrical insulator. If it doesn't conduct heat, it's a thermal insulator. So if X is in solid form, it doesn't conduct either heat or electricity. So that's the first clue, okay? And then which of the 6 substances are good conductors of heat and electricity? Now, we already identified some of the materials as metals, some non-metals, and silicon being a metalloid, which would also say it's a semi-metal. Now, the question says which of these 6 substances are good conductors of heat and electricity. So it's both thermal and electrical. So of the 6 substances, okay, we know that copper as a metal, actually most metals are actually good thermal and electrical conductors. So copper is actually a good conductor of heat as well as electricity. So from the list, we can identify that copper has that physical property, right? Okay. Now, what are some of the properties of metals that we need to remind ourselves of? We know that metals are generally, they are good electrical conductors. It means they actually easily allow electric charge to actually pass through them, okay? And also they are good thermal conductors. So the main idea here is to understand that metals are both good in terms of allowing heat as well as electricity through them. Hence we talk about electrical as well as thermal conductivity as a physical property. Right, and also most metals are ductile. If you pay attention to the attachment there that we have, which shows that copper can be drawn into fine strands, okay, without breaking. So copper is ductile, while at the same time we are saying that most metals are actually malleable. Not all, we are saying most of them. And malleability actually has to do with the ability of a material to be molded into any shape without it actually snapping or breaking. Right. So these are some of the key properties of metallic substances. Right. Okay. Now, here is a list of these substances again. Now we've got silicon. Silicon, there's something special about silicon. We are saying silicon has both metallic and non-metallic properties. And then we said that silicon is actually a metalloid. Okay. So what is a metalloid? A metalloid is actually a semi-metal. So metalloids are actually semi-metals, right? So these substances have actually a combination of metallic as well as non-metallic properties. Let's keep that in mind, right? Okay. Now, what about semi-metals? That is very important. They are actually poor electrical conductors at low temperatures. Now, let's understand something. These, the major, property of semi-metal is that their conductivity actually depends at the temperature in which they exist. At a lower temperature, they are actually bad conductors, but at a comparatively higher temperature, they actually become better electrical conductors. So their conductivity actually improves with temperature. That's a very important note to take into account. And then also, semi-metals are good electrical conductors at high temperature. So the temperature affects their conductivity. So that example in the 6 of the substances that are given, silicon becomes that semi-metal or the metalloid. Right, okay? Right, and then we also have chlorine. Chlorine is a non-metal, okay? And then we would also say that in terms of classification, would find, or it would occur on the further right end of the periodic table of elements. Let's look at what's so special about non-metals. Something that stands out about them is that they are both poor, electrical as well as thermal conductors. So most non-metals, they do not conduct electricity and they do not transfer heat energy easily. So they are good insulators, both thermal as well as electrical. That's what is so special about non-metals. Now let's look at some of the most important properties of semi-metals in terms of what exactly stands out in as far as semi-metals are concerned in comparison to other materials that are on the periodic table. We are saying that all semi-metals are actually poor electrical conductors. So poor electrical conductors are actually good insulators, but this poor electrical conductivity is only prevalent at very low temperatures, okay, while good electrical conductors at high temperatures. So this takes us to a very important realization to say that the electrical conductivity of semi-metals or metalloids entirely depends on the temperature in which they exist. So in other words, we are simply saying that at low temperatures, they tend to be, poor electrical conductors, but as their temperature increases, they essentially become better electrical conductors, right? Okay, that's very key. Okay, so we understand a lot about, semi-metals, which is silicon, and also we've got other non-metals like sulfur and chlorine. What's so special about these non-metals? They are poor electrical and thermal conductors, generally, all non-metals. And remember, these non-metals actually occur further to our right of the periodic table of elements, right? Okay, now, we're still talking about the list. Now let's zoom our attention to sodium chloride and water. There are some, similarities between these two substances that we need to take into account. What are these? Okay, it says here compounds have different physical properties. In other words, both water and sodium chloride are actually compounds. Now, we've said that the term compound is one of the key terms in our discussion. What are compounds? Compounds are these substances that are made up of two or more different elements that are chemically joined together. So it's not an element, a single element that is joined together. It should be different, then it makes up what type of a material? A compound, right? So water is a poor electrical and thermal conductor in all states, be it solid, liquid, or gas, while sodium chloride is a poor electrical and thermal conductor as a solid, but conducts electricity as a liquid or gas, because this has entirely have to do with the composition or the makeup of sodium chloride, which distinguishes from water. So sodium chloride will be made up of free moving ions when it is dissolved in water. In other words, it says to us that sodium chloride is completely soluble in water. So these are some of the physical properties that we need to understand before we can actually identify our substance X. Now, we're told that substance X does not conduct electricity or heat as a solid. What does that tell us? It means it is an insulator. So if it, as a solid, we can take out copper, because copper is actually an electrical conductor. So we've eliminated the copper because we're saying X does not conduct. So copper does, because copper is a metal, right? Okay. And then moving along, we also told that on our second clue that substance X is non-magnetic. Remember, magnetic materials contain the ferromagnetic elements, which is iron, nickel, and cobalt. So we're told that X is non-magnetic, so it doesn't contain any of the ferromagnetic elements that we know of, okay? This leads us to say that what is a magnetic material is those that can be acted upon by a magnetic force in a magnetic field. We'll talk to that in more detail. So these ferromagnetic elements are iron, nickel, and cobalt. So sometimes we call them the ferromagnetic elements, right? So that's the description. Yes, they are elements because they are on the periodic table and they consist of atoms of the same kind, each one of them, okay? And then we've taken out copper based on those, the understanding that this material is non-magnetic. Having said that, we'll continue to drop more clues such that we will be able to eliminate more and more from the SIG. So we've taken out the copper. Now our next clue is also going to guide us in terms of eliminating from the 5 remaining possible options. Let's take a short break for now. Welcome back to our third and final segment. We're still looking into the game that matters in terms of the physical properties. So up to now, we've managed to identify, some of the possible options which are definitely not related to what substance X is. Now let's look at more clues. In the previous segment, we spoke about solubility as a property of a material, in terms of it dissolving to form a solution, whether it's completely soluble or partially soluble. So solubility is the extent to which a substance dissolves in a solvent to form a solution. Now, if a substance does completely dissolve, then it's soluble, while if the opposite happens to a smaller extent or not dissolving at all, then we'll describe that substance as insoluble. All right, so solubility, we are saying that sulfur is insoluble in water. So sulfur actually does not dissolve in water, okay? And silicon is also insoluble in water. Chlorine dissolves completely in water, hence we're saying chlorine, it's soluble, while sodium chloride is completely soluble in water. Okay, where does this lead us? It says to us that definitely sulfur and silicon are definitely not are not exactly what we are looking for in terms of the identity of substance X. So we're left with 2, okay? The reason why we took out sulfur and silicon is based on their solubility, okay? Right? It's based on their solubility. So if something is soluble, it means it dissolves completely. Now we're told that X dissolves completely in water. Now, if we look at sulfur and silicon, which silicon is a semi-metal while sulfur is a non-metal, it says to us that these two cannot be substance X, right? Moving along, then the other keyword that has to do with electrical conductivity. When we talk of an electrolyte, right? An electrolyte is actually an ionic substance that is dissolved in water, and while it does that, it will allow electricity to pass through. So an electrolyte is an electrical conductor. So let's keep that in mind as a property of solubility, right? And then it says here, if a substance is an electrolytic solution, let's look at sodium chloride as an example. A sodium chloride solution is a good electrical conductor, okay? So it is an electrolyte. So we'll describe it as an electrolyte because when dissolved completely in water, it allows electricity to pass through and then it becomes a conductor, right? Then a chlorine solution is a poor conductor, meaning that it is an insulator, right? And then we're definitely going to take out part of the chlorine, because chlorine is a non-conductor, because this is an insulator. Yes, it is soluble in water. So, but at the end of the day, this is an insulator. Okay, it is an insulator, right? While it is completely soluble in water, it does not allow electricity to pass through it. Now, we're onto something here. Now, we are saying that substance X has the properties like the 1 over 6. Then we are saying that after eliminating 5, of the possible 6 options, we are left with only one option, which is sodium chloride. Then it simply means to us that X is indeed sodium chloride. But how exactly did we arrive at that? We appreciated the fact that we need to understand the physical properties. We went to the periodic table, we looked at the trends, at the periodicity, we understood that materials or substances that fall within the same group, they've got similar physical properties, while if we consider the horizontal rows, which are the periods, the physical properties will differ, okay? Right, now, having said that, let's understand something about sodium chloride based on the physical properties. One thing for sure, sodium chloride is a compound. Why is it a compound? Because it consists of 2 different materials or 2 different substances that are chemically joined together, which is a metal, which is sodium, which is a metal, okay, while chlorine is a non-metal, okay? Now, this is a compound in the sense that it's a combination of 2 different elements joined together. Hence, we would classify sodium chloride as a typical compound. It is a poor electrical conductor. If something is a poor electrical conductor, we are saying it is an insulator, okay? Poor electrical conductors are actually good insulators as a solid, but good electrical conductors, it is an insulator as a solid. Why? Because it consists of ions, but if these ions are not moving, then electric charge cannot be transferred through it. Now, in other words, we are saying it becomes a good electrical conductor in a fluid, which is a liquid or a gas. So that's the whole idea about sodium chloride. And furthermore, we are also saying that in terms of solubility, it dissolves completely in water to form an electrolyte. Remember, electrolytes are only formed when an ionic substance completely dissolves in water, and then these ions are free to move through it. We'll talk about electrolytes more in detail as we look at the periodic table at a later stage. Right. And then also, the microscopic in terms of the particle nature of sodium chloride. It consists of ions of chlorine as well as of sodium. So chloride ions have got a negative charge, okay? So these ions, we call them N ions. Any ion that has got a negative charge is called an N ion, while those that are positive is called a cation ion, right? So this is the chemical composition. So in other words, we can simply say that sodium chloride is an ionic solid. So if we say it's an ionic solid, what does that say to us? It says under normal circumstances, we find it in solid form, unless, of course, it has been dissolved in water. And now that tells us that sodium chloride is actually completely soluble in water as far as solubility is concerned. Right, okay? What more? Substance X is an ionic solid that contains chloride ions. Now we are told, okay? Now that's another clue, okay? We're going further. Now we've identified X. Now we at a different stage, we are saying, okay, here's another substance, which we still call it X because it's unknown. It contains chloride ions, okay? That's the first clue. So substance X has properties like one of the 6 that are given, okay? There are also no particles in X that are not present in the 6 substances. What does that tell us? It tells us that all these 6 substances that are given as possible options of what X could be are actually consisting of particles. Now, our job is to our task is to establish the identity of substance X, right? Okay. Now, substance X could be a combination of one of the more than one of the 6 substances that are given. So if you come to think of it, copper and chlorine, a combination of these 2, if they react together, they can form a substance, okay? That substance is actually copper chloride, which is in solid form because it has similar properties to those of sodium chloride, because what is common is that both of them, they contain chlorine. Take note, the name is chloride. Okay, not chlorine. It means chlorine is a component of this compound, okay? And what is a compound? It's a combination of 2 substances that are different and they're chemically joined together, copper being a metal, while chlorine being a non-metal. So that's what has been consistent in terms of the composition, right? And then again, we are told that substance X is copper chloride, okay? it's given. Now, a blue or blue-green solution indicates that copper ions are present, because if this substance completely dissolves in water, it forms that homogeneous solution, which is actually blue in color. And the color indicates the presence of copper ions, okay? Right, and then in summary, what are we saying? Matter can be classified into different groups based on physical properties. So one cannot overemphasize the importance of us understanding the physical properties of material, so that we are able to classify them or categorize them, whatever it respects, in terms of, you know, their behavior, you know, the packaging of materials, you know. But the physical properties are very central in as far as the periodic table is concerned. So to find materials or elements within the same group, because they show or they display similar properties, that's what is important in as far as, you know, the physical properties. So elements are arranged in the periodic table according to their properties. We've mentioned that, okay? So properties of matter are explained by studying the microscopic model. So when we look at the chemical composition, you know, at a particular level of a material, we are able to understand its properties, because how a particular material behaves, or, you know, whatever happens to it, is based on how these particles are arranged. It could also relate to, you know, the state in which it occurs under different conditions. Can it be a solid, liquid, you know, gas? Does it dissolve? Is it able to, you know, conduct electricity? Is it a thermal conductor or insulator? All those are actually based on the microscopic, you know, composition of that particular material, right? So it's very, very important for us to understand that. But over and above, we are saying that the periodic table of elements, you know, is arranged in such a way that substances are in an order of sequence, you know, in terms of their physical properties. So very, very important is that, you know, if elements or substances fall within a particular group, they more or less show the same physical properties. So there is a special, you know, sequence in the periodic table, something that we'll look into detail in terms of what we refer to as the periodicity, or the trends, the patterns in terms of the properties, right? Okay. Okay. Now, in the sense of, you know, understanding the periodic table, we are saying that the main idea is to understand the physical properties of materials. So once we are able to identify a particular material and be able to speak to its individual properties, we are able to understand further the applications of that material in terms of the everyday life use. So it all comes together in as far as the physical properties. Hopefully it does make sense, but the idea is to also, you know, given a material, you must be able to say, okay, this material, is it a pure substance, or you know, an impure substance? Is it an element or a compound? If it is in an element, in which group does it occur, and then in which period? Particularly with the group, it also becomes important in terms of the physical properties within that particular group. For today, that's as much as we can cover in as far as the physical properties of material. From myself, Temba Ngube, cheers and bye-bye.